The National Institute of Water and Atmospheric Research NIWA is a Crown Research Institute of New Zealand. Established in 1992, NIWA conducts commercial and non-commercial research across a broad range of disciplines in the environmental sciences. It also maintains nationally and, in some cases, internationally important environmental monitoring networks, databases, and collections. As of 2014, NIWA had 610 staff spread across 16 sites in New Zealand and 1 in Perth, Australia. Its head office is in Auckland, with regional offices in Hamilton, Wellington, Christchurch, Nelson, and Lauder. It also has small field teams, focused mostly on hydrology, stationed in Bream Bay, Lake Tekapo, Rotorua, Turangi, Napier, Whanganui, Greymouth, Alexandra, and Dunedin. NIWA maintains a fleet of about 30 vessels for freshwater, marine, and atmospheric research. Mission statement. NIWA's mission is to conduct leading environmental science to enable the sustainable management of natural resources for New Zealand and the planet. History. NIWA was formed as a standalone organization in 1992 as part of a government initiative to restructure the New Zealand science sector. Its foundation staff came mainly from the former Department of Scientific and Industrial Research and the Meteorological Service, the Fisheries Research Division of the former Ministry of Agriculture and Fisheries joined NIWA in 1995. Research programs. NIWA focuses on atmospheric, marine, and freshwater research, extending from the deep ocean to the upper atmosphere in New Zealand, the Pacific, Southern Ocean, and Antarctica. NIWA's research spans diverse fields: aquaculture, aquatic biodiversity, aquatic biosecurity, atmospheric science, climate change, coastal ecology, energy, fisheries, hydrology, marine geology, natural hazards, oceanography, sedimentology. Research projects are undertaken in collaboration with local and central government agencies, other Crown research institutes, industry, private research companies, and universities in New Zealand and the rest of the world. In 2007-08, NIWA scientists were involved in more than 970 collaborations, and NIWA had formal links with some 150 overseas institutions. Within New Zealand, NIWA has close working relationships with many Maori entities through its Maori Environmental Research Group, Te Kuaha o Taihoronuku Rangi. Most of NIWA's revenue is from contestable research funding and commercial consultancy work. As of 2014, NIWA had a revenue of $123.8 million and assets of $103.6 million. NIWA's scientists. NIWA's greatest asset are its scientists and technicians who come from all over the world and hold expertise in a wide range of disciplines, from atmospheric science to zoology. In 2007-08, NIWA employed 501 permanent researchers. In 2014, NIWA researchers contributed to more than 353 peer-reviewed science publications and delivered more than 639 science presentations and conference papers. In 2007, 12 NIWA climate scientists, Greg Boettger, Matt Dunn, Rod Henderson, Darren King, Keith Lassie, David Lowe, Brett Mullin, Kath O'Shaughnessy, Guy Penny, Jim Renwick, Jim Salinger, and David Ratt shared the Nobel Peace Prize with other contributors to the Intergovernmental Panel on Climate Change. NIWA scientists also play a role in training future scientists and in public outreach through talking about the science to community groups, school children, media, and the general public. They also contribute to professional development training courses for environmental agencies in New Zealand and the South Pacific. Research facilities. NIWA's wide-ranging research facilities include a gas laboratory which uses gas chromatography and mass spectrometry to assess the composition of gases and their isotopes in samples of air and water, and isotope analysis of solid material, an ecotoxicology laboratory for assessing the effects of contaminants such as heavy metals, pesticides, and wastes on aquatic organisms, aquaculture research facilities at Bream Bay in Northland and at Mahango Bay, Wellington, an upper atmosphere research laboratory located at Lauder, Central Otago, New Zealand. Additionally, NIWA also operates a suite of atmospheric in situ and remote sensing instruments at Arrival Heights, Ross Island, Antarctica. Lauder Atmospheric Research Laboratory. The NIWA Lauder Atmospheric Research Laboratory takes atmospheric measurements for the purpose of observing and better understanding interactions between the stratosphere, troposphere, and global climate. This is achieved through measurements of ozone, solar radiation, aerosols, and greenhouse gases. There are approximately 10 staff working at the laboratory. Location: Lauder is located 33 kilometers northeast of Alexandra in the South Island of New Zealand. This location was chosen for the laboratory due to the area's low horizons, clear skies, dry atmosphere, and southern latitude location. Research history. A research laboratory was originally established at Lauder in 1961 with the purpose of observing the aurora. In the mid-70s, Lauder was a ground tracking station for the satellite ensemble International Satellites for Ionospheric Studies. By the late 1970s, research had shifted focus to the stratosphere. This shift was driven by the fear of ozone depletion due to manufactured gases, and by the time the ozone hole was discovered, Lauder had begun measuring UV radiation, ozone, and other gases associated with ozone depletion. For the 1990s, Lauder has also monitored the effects of ozone depletion on solar UV radiance. Recently, research at Lauder has focused on interactions between climate change and ozone depletion, and Lauder now measures most gases that contribute to climate change. Computer models to predict future atmospheric changes have also been developed at Lauder, and the atmospheric measurements taken at Lauder are used in climate models around the world. Measurements of the atmosphere at Lauder can be carried out in situ and through remote sensing. In situ measurements are mostly done at ground level. However, balloons are launched weekly and carry out in situ measurements through the atmosphere to altitudes of approximately 30 kilometers. Data from these balloons enables atmospheric profiles of temperature, pressure, water vapor, and ozone to be produced. One method of remote sensing measurements at Lauder uses a LiDAR system to generate ozone profiles to 100 kilometers in altitude. Another LiDAR measures aerosols in the atmosphere to 50 kilometers in altitude. Other remote sensing at Lauder uses UV, vis grating, and FTIR spectrometers to measure trace gases in the atmosphere. Measurements at Lauder are also used to calibrate satellites such as OCO2 and GEO-SAT. Importance. The Lauder Atmospheric Research Laboratory is well known throughout the international world of atmospheric research through its participation in the International Network for the Detection of Atmospheric Composition Change, BSRN, TCCON, and GCOS Reference Upper Air Network. Lauder has many ongoing long-term measurements, including the longest time series of nitrogen dioxide in the world. The laboratory is located in a data-sparse region of the globe. The oceans of the Southern Hemisphere and the Antarctic region play an important role in the global climate system, and some measurements taken at LORDA are valuable to the global scientific community. Solar radiation measurements at LORDA are used in studies on the effects of UV radiation on human health and in the solar energy and building industries. NIWA vessels. Foremost among NIWA's 30 vessels is the 70 meters deep-water research vessel RV Tangaroa, New Zealand's only ice-strengthened research ship. The 28 meters RV Kaharoa is used mainly for coastal research, but has gone further afield to deploy ocean profiling Argo floats. From Chile to Mauritius. Environmental monitoring networks. NIWA maintains a range of monitoring networks that collect long-term environmental data, including climate information, sea level, river flows, water quality, and freshwater fish distributions and habitats. As at the 1st of August 2008, NIWA had 1339 operational stations in its climate and water monitoring networks, spread throughout New Zealand, including the Chatham Islands. NIWA also holds data from more than 3,000 closed stations, many of which have long usable records. The National Water Quality Network, for instance, has been operating at 77 sites since the 1970s. It can now show long-term trends in water quality. Environmental data. NIWA maintains several databases containing long-term records of environmental data and species records. The National Climate Database, for instance, contains more than 250 million individual measurements, with records dating back to the 1850s. The New Zealand Freshwater Fish Database records the occurrence of fish in freshwaters of New Zealand, including major offshore islands, and details of the habitats. As of June 2009, the database included more than 28,000 records. Among other things, these databases are used to detect geographical and temporal trends in the state of the environment. NIWA holds the longest continuous record of atmospheric CO2 concentrations in the Southern Hemisphere, measured at Bering Head, near Wellington, since the 1970s, along with equivalent measurements from the Northern Hemisphere taken at Mauna Loa Observatory in Hawaii. These records are used to model the effects of atmospheric CO2 on global climate. The information in NIWA's databases is in high demand. In the 2007-08 financial year, for instance, NIWA responded to more than 350,000 requests for data from its databases. In July 2007, NIWA allowed free online access to archived data on climate, lake levels, river flow, sea levels, water quality, and freshwater fish. NIWA Invertebrate Collection. The NIWA Invertebrate Collection is the largest repository of marine invertebrate specimens from the New Zealand region, Southwest and Pacific, and the Ross Sea. It holds representatives of almost all phyla in the New Zealand region, collected over the last 50 years and still growing. The collection holds several million specimens, ranging from single-celled organisms to giant corals. As of 2015, it included over 2,100 type specimens of species new to science. The collection is used by scientists, teachers, and journalists throughout New Zealand and the world. Natural Hazards Center. In 2002, NIWA teamed up with the Institute of Geological and Nuclear Science to create the Natural Hazards Center as a New Zealand resource for all hazards information and advice. The center develops systems to monitor and predict the following hazards: earthquakes, tsunami, floods, storms, landslides, coastal flooding and waves, coastal erosion, and volcanoes.